Once again, welcome to today's lecture. Whether my presentation is visible to you?
Yes, sir.
Okay, thank you. So today's discussion is about the characteristics of database approach, or what are the various features of your database approach. So these are the topics to be covered as part of today's presentation. So after completing the discussion with respect to the characteristics of database approach, if we have some time, I will try to cover the next concept, personnel involved in the DBMS environment. So you will be having actors on the scene and workers behind the scene. Okay. So who are all the persons interacting with the database environment? So what is the role of each and every person that we will try to identify. Okay. So first we will start with the characteristics of the database approach. So in your textbook, the authors have listed 4 characteristics associated with the database. So the first characteristic is self-describing nature of a database system. So first characteristic is self-describing nature of a database system. Second one is insulation between programs and data abstraction. Third characteristic is it support of multiple views of the data. So fourth one is sharing of data and multi-user transaction process. Or in other words, what I can say is you don't have support for these features in your traditional file processing system. So these are the unique characteristics associated with your database system or a database approach. So what is the first characteristic? First characteristic is self-describing nature of a database system. So the fundamental characteristic of a database system is, so what your database system is going to have is, in addition to your database, that is in addition to the data, what it is going to do is, it is going to store the information about the, or it stores the complete definition or the description of the database structure. So what is the structure associated with the database and what is the constraint? So in addition to the database, it stores the information about the description of the database structure and what are the various constraints. So these information are stored in the form of a DBMS catalog. So if you take a database system, so if you remember the last class lecture, the last class diagram, so in the bottommost layer you will be having what? You will be having your database along with your metadata. Metadata is nothing but what? Metadata is nothing but your DBMS catalog. So if you take a database management system, your database management system is a general purpose software. That is, it is not written for a specific database application. So now, if it is not written for a specific database application, then what is required is, so from the database management system point of view, it needs some mechanism to locate and to retrieve the data. So what it is going to do, whenever as a user, whenever you are going to supply a query, what your database management system will do is, it will go and refer to this catalog. So from the catalog, what it infers the structure of the file. So again, be clear, we are using the term database. Okay. So logically the data, so for the user, when you extract the data, logically the data will be displayed in the form of a table, or in the form of rows and columns, or in the form of a matrix, or in a 2-dimensional format. So if you see the if you see the storage physically, it will not be stored in the form of tables. Actually, it will be stored only in the form of files, or it will be stored only in the form of records. Because of that way, here we are using the term as files. So from the catalog, if you so your DBMS, what your DBMS will do is, it will refer the catalog to retrieve the structure of the database. So the structure consists of what? Structure consists of the type and the format. So what is the data type and how the data is stored? If it is going to be a record, so whether the record is stored in the form of spanned records or unspanned records. So all those information will be determined based on the information that is available in your DBMS catalog. Now, so what we have discussed in the previous slide, your DBMS software is a general purpose software. So here I have listed some application. So for example, you can create a database for a university, for a bank, or for a company. So here the domain, okay. So the database is related to different scenario or different application. For each and every database, we are not going to use a separate database management system. So you can use a separate database management system. You can use the same database management system with a variety of application. So now what is the major difference is, if you take your traditional file processing system, in the case of your traditional file processing system, this definition, okay. So in the case of your database system, your data definition or the data structure is stored in a separate DBMS catalog. Whereas here, your data definition will be part of your application program, or your data definition is closely tied with your application programs. So what is the major drawback? So you are going to have a program, so that what is the limitation with respect to this program? So this program will work only with that particular file or only with that particular database. So whose structure is declared in that application program. So now you are having a program. So now the thing is, so what is the limitation is, if you change the structure, your program won't work. So I cannot say it won't work. In some situation it may work, but it may generate a what? It may generate a inconsistent data, or it may generate a inconsistent output. Not inconsistent data, it may generate a incorrect output. Not inconsistent, incorrect output. So actually this is a diagrammatic representation of your simple DBMS catalog. So for example, you assume that you are having a database related to a university. So inside the university table, what are the relations we are going to have? Relations are nothing but tables. So inside the university database, I am having 5 tables. So what is the name of each and every table? Student, course, section, grade report, prerequisite. Like that, I am having 5 different tables. So in each and every table, the second column gives you the number of columns. So if you take the student table, I am going to have 4 columns. So if you take the 4 columns, okay. So if you take the course table, you are going to have 4 columns. Okay. So the thing is, so 4 columns. So what is the column name? So you are so inside the student table. So inside the student table, so what are the fields I am going to have? I am going to store the name of the student. I am going to store the student number and class. So this is the field name along with the what? Along with the data type. So what is the data type? So for student name, the data type is character with this 30. For student number, data type is character with this 4. So like that. So this information is available inside your DBMS catalog. So I think 1 column is missing here. Sorry. Okay. So here you are having 4 columns, but actually I have copied only 3 columns. Okay. So 1 column is, I think you are having some prerequisite. So that column is missing. Okay. So second characteristic. So clear. So what is the first characteristic? Self-describing nature of a database system. So what is the concept is, if you take a database system, in addition to the database, it will store the information about the structure of the database. Structure consists of what? Structure consists of your type and the constraints. So for each and every column, what is the data type of each and every column? What is the constraint? Whether it is going to be a primary key or foreign key, or you are having a check constraint, not null constraint. So like that, what are the various constraints associated with that particular field will be stored as part of your DBMS catalog. If you take a DBMS, most of the DBMS database management system comes under the category called as general purpose software. So for the thing is, what I am trying to say is, so your DBMS is independent of application. So if it is a university database, or it may be a bank database, it may be a company database, it may be a railway reservation database. So irrespective of the application, you can use the what? You can use the same database management system for creating, for manipulating the data that is available inside that particular database. So the limitation is in the case of, what is the difference is in the case of file processing, your take, so you don't have what, the structure is not stored separately. The structure of the data is stored as part of the program itself. So if you modify the structure, you need to modify the program. So your program may not or it may not generate the what, your program may not generate the correct result. So that is the concept related to your self-describing nature of a database system. So in continuation to that, what is the second characteristic? Second characteristic is insulation between programs and the data. So this is continuation of the previous point. Okay. So if you take the traditional file processing system, so what we have discussed, so the data definition is stored as part of the application program. So your data files is embedded in the application program. So what is the limitation? If you change the structure of the data file, you need to modify the program. If you are not going to modify the program, your program may generate incorrect result. So if in the case of traditional file processing system, you don't have support for program data independence. So if you modify the data, there is need to modify the program. Whereas in the case of your database management system, there is no need to modify the program because the structure is available separately in your DBMS catalog. You can add some additional fields, or you can remove some of the fields from the existing definition. So irrespective of some addition or deletion, your program will work. It is not going to generate any inconsistent, it is not going to generate any incorrect result. So in the case of DBMS, we have support for what? We have support for program data independence. So if you move, the thing is, if you move the data from one location to another location, or if you modify the organization of data, there is no need to change the program. So that is the idea behind program data independence. So second thing is called as program operation independence. So what do you mean by program operation independence? So if you take some recent some advanced database like object-oriented database or object relational database. Okay. So currently our focus is with respect to the traditional database, relational database. Suppose if you are going to use object-oriented database and in object relational database, so what is the option you have is, as a user, you can create some operation. You can create your own operation. So user-defined operation will be stored as part of your database definition. What is an operation? An operation is similar to what? It is a function or it is a procedure similar to a method. So I can refer an operation as a function or a method. So whenever we use the term function or a method, it consists of two parts. One is the type signature, another one is the definition. So here we are going to refer it as what? Each and every operation consists of two parts. One is the interface and another one is the implementation. So interface is nothing but type signature. So what is the, how you are going to use that function? So implementation is code inside that particular function. So now here, so the thing is, so what is the idea behind your program operation independence is, see, suppose without knowing the implementation, from the user point of view, it is enough if I know the type signature to invoke that particular function. Another thing, what they are trying to say is, if you, with respect to this program operation independence, if you modify the interface, or you can modify the interface without modifying the implementation, or you can modify, okay, so vice versa, both are possible. So I can modify the type signature of the method without modifying the code, or I can modify the code without correcting the, or without changing the type signature or your interface. So that is the idea behind your program operation independence. Okay. One simple thing, what they see, suppose you assume, suppose as an example, what I can say is, suppose you assume that you have created an interface, for example, sort. So, as a user, what I told you, you are least bothered about the implementation. So the thing is, so it is enough for the user to know the function name, how to invoke the function, what is the input that is to be passed to that particular function. So for sorting inside that, the definition may be what? The code may be or the method or the program may use bubble sort or keep sort or wedge sort. Okay. So now what is the idea is, so initially you have developed this with the bubble sort. If I modify it as a merge sort or keep sort, there is no need to modify the interface. The function name will remain the same. I can modify the implementation. So that is the idea behind what? That is the idea behind your program operation independence. So combinedly put together, this program data independence and program operation independence is called as data abstraction. So already you are familiar with this now. Okay. So now most of your database management system provides the users with the conceptual representation. So it is going to provide a conceptual representation of the data. So what is the limitation with respect to your conceptual representation is, so it will not expose how the data is stored or how the operations are implemented. So these two informations are hidden from the user. So that is the idea behind your insulation between programs and the data. So that is the second characteristics of your database approach. And what is the third one is, it provides support for multiple views of the data. So the thing is, if you take a database, usually a database is associated with many types of users. So each and every user is interested in visualizing the data in a different dimension. So for example, again, if you take the same example what we have discussed in the last class with respect to the university database, so that suppose if you take a person who is working in examination wing and another person who is working in the administrative office. These two persons, they may be interested in accessing the same database called or same table called the student, but they are interested in visualizing the information from student in a different angle. So the person in examination wing is interested with respect to the grades, whereas the person in administrative office is interested in visualizing the details related to the fee payment. So what is the requirement from your database management system is, each and every database management system needs to provide multiple views, support for multiple views. And another thing is, see, certain data is called as what? Certain data is called as stored data and certain data is called as derived data. So what is the idea behind derived data? Derived data means it is not physically stored or it is not stored as part of your table. So one simple example is, so if I know suppose I am storing the information about the student in a table. It is enough if I store the date of birth. There is no need to explicitly store the age. So if I know the date of birth and the current date, simply I can subtract and I can compute the age. So your date of birth is an example for stored data and your age is an example for derived data. So, and this information is not known to the what? This information is not known to the end user. So, what the end user is going to do is, end user is going to supply a query. Your database management system will evaluate the query and it will return the result. So, whether the result written by your database management system is going to be a stored data or derived data, that is hidden to what? That information is hidden or that information is not known to the user. Okay, so basically, so you are having a term called as view. So what is the difference between a table and a view? So depending upon your requirement, you can create a table or you can create a view. So table means whenever you create a table, it is a physical entity. Physically, storage will be allocated. Directly, you cannot create a view. If you want to create a view, you can create a view for an existing table. So your view is nothing but what? Whenever I use the term view, view is nothing but a virtual table, or it is going to, or it contains the what? It contains the non-existent data, or it contains the virtual. That is, non-existent data means the data is not part of that particular view. So what? See, I can have a table called the student. For the table student, I can create a view called as view student. So now, what is the difference is memory will be allocated for the table student, memory won't be allocated for the view called as view student. So whenever you execute a query against the view, the thing is what your data, so the query will be evaluated based on the values that is available in the table, not based on the. So you may ask a question, then what is the need for a view? Directly I can access the table. See, suppose in some situation your table, the number of fields in the table may be more. I want to create a table, or there may be a need to create a new table which is going to be a what? Subset of the old table. So in that case, instead of creating a new table, I can create a view. So your view may have a what? A subset of the fields that is available in your old table or in the existing table. So that is the idea behind your support of multiple views of the data. Clear? So certain data may be stored data and certain data may be derived data. Okay, so these informations are not exposed to the user, or whether the data is stored data or derived data is not exposed to the end users. Okay. Okay, so this already I have explained with a different example. Okay. So now, see, for example, with respect to the student table, you are having two users. So what is the requirement of the first user? First user is interested in accessing and printing the transcript or the mark sheet of each and every student. You may be having a second user. What is the need of the second user? So the second user needs to ensure whether each and every student has completed the prerequisite for a given course. So all this information is available in a single table called the student. So now what is the inference is, both the users are accessing the same table called the student, but for the thing is what? They are interested in retrieving different information from the same table called the student. So the output is not going to be the same. The output, so in the first case, the output is going to be the mark sheet of each and every student. Whereas in the second case, so it is going to be what? Yes or no, whether the student has taken the prerequisite course or not. So that is the difference. So your DBMS, database management system, should provide support for creating multiple views or for defining multiple views. So the last characteristic is sharing of data and the multi-user transaction processing. Okay. So mostly your database management system is going to be a multi-user database management system. So if you are going to have a database, so the main idea is what? So whenever you want to share the data among multiple users, you will store the data in a database. After storing the data in a database, and if you are going to allow each and every user to access the data in a sequential fashion, then the waiting time will be more. So now we want to reduce the response time for each and every user. So how to reduce the response time? If you want to reduce the response time, you need to allow multiple users to access the database concurrently. Now again, this concept is what? Similar to your read-only file or read and write file. If you are having n users, if all the n users are interested only in performing read operation, and you allow all the n users to perform the read operation against the database, it won't lead to any inconsistency. Now the problem is, you are having two users. One user is interested in reading and another user is interested in updating. So updating the what? Updating the same data. Then finally it may lead to what? It may lead to inconsistency. So in DBMS, so what is the requirement of your database management system is it contains one separate module called as concurrency control module or concurrency control software. So what is the responsibility of this concurrency control software is it ensures each and every transaction is executed in a properly fashion. So and another thing is whenever we use the term transaction, it needs to satisfy some property. So that I will explain in the next slide. How will you define a transaction? So what is the definition for a transaction and what is the properties associated with the transaction? So now what is the need for this concurrency control? So if you don't have proper concurrency control, what is the problem you may face? So they have given an example. So you consider a airline reservation system. So now the thing is your database is located in a single location, or suppose as of now, for simplicity we assume that your database is going to be a centralized database. Agents from various locations will access the database to perform the reservation process. Now what is the requirement is key. So your system should ensure that a seat is allocated only to a particular person, or it is assigned only to a particular agent, or it can be accessed. A particular seat number can be accessed only by a single agent at a given time. See, suppose if you are going to assign or if you are going to allow multiple agents to access the same time, the same seat number will be booked for more than one passenger. It leads to inconsistency. Actually, it is not the correct functionality. So this type of case, so for these type of applications, what is the requirement is these applications comes under the category called as online transaction processing application. So your airline reservation is an example for what? OLTP, online transaction processing application. So so in the last class we have discussed with respect to the first 4 database application, reservation, online purchase, your database with respect to a bank performing withdrawal operation, deposit operation, all those things comes under the category called as what? The online transaction processing. Now, so how will you define a transaction, or what is a transaction? Your transaction is nothing but an executing program. So now what is the difference? So the thing is simply here it is mentioned as an executing program. Now you can have a C program. So when that particular C program is called as a transaction. So what is the difference between a normal program or when the program can be called as a transaction? So whenever we use the term program, you are going to have some set of instruction, or you are going to have some sequence of instruction. Now, as part of the instruction, suppose if you are going to have one or more instructions pertaining to database access, such as reading, or reading means what? A select or update operation, then it comes under the category what? Then that particular program comes under the category called as a transaction. So each and every transaction needs to satisfy the property called as the ACID property: atomicity, consistency, isolation, and the durability. ACID. So in short, we will call these 4 properties as the ACID properties. Okay. So quickly I will. So the thing is, atomicity means all or nothing property is called as what? All or nothing property is called as atomicity. So if you start a transaction, simply you cannot abort the transaction in the middle. So what you need is either you need to execute all the instruction or none of the instruction. So that is the idea behind your atomicity. So consistency means when you execute a transaction, your transaction should move the database from one consistent state to another consistent state. So after completing the transaction, your database should not be in an inconsistent state. Isolation means, suppose if you execute more than one transaction or simultaneously, if you execute more than one transaction at a time, the intermediate value generated by the one transaction is not visible to the another transaction. Till the transaction executes the commit command, it is not visible to the another transaction. That is the idea behind your isolation. And finally, durability means once the changes are made permanent, you cannot perform any undo operation. Suitably, what you need to do is you need to execute the alternate transaction. That is, so simply you cannot once the transaction execute the commit command, the changes will be made permanent in the database. Once the changes are made permanent, so if you want to modify, once again what you have to do is you have to execute a suitable transaction. Just like that, you cannot perform any undo operation. So that is the brief information about these four properties, namely atomicity, consistency, isolation, and the durability. So again, okay, I think yesterday itself I have shown the same slide in a different context. Difference between OLTP and OLAP. Okay. So your OLAP is with respect to your data warehouse, OLTP is with respect to your database. So these are the parameters. Okay. So with respect to OLTP, user is going to be a clerk. With respect to OLAP, user is going to be a knowledge worker. So what is the function? OLTP is usually day-to-day operation, and OLAP is used for making decision. Okay, so these things already we have discussed. So what about the size? So obviously your data warehouse size is going to be what? Very huge when compared to your database. So this is not required for your examiner. This is for your some additional information. So that is with respect to the characteristics of a database system. So what are the characteristics? First one is self-describing nature of a database system. Second one is insulation between programs and data abstraction. Third one is it provides support for multiple use of data. And fourth characteristic is sharing of data and the multi-user transaction process. So if you are having any doubt, you ask me now itself, I will clarify, and then I will continue with the next topic. If you need any clarification regarding the concept what I have explained so far, you can ask, I will explain.
Sir, once again repeat ACID, sir.
Louder please, your voice is not audible to me.
Once again, can you explain the ACID, sir, atomicity?
You want me to explain that acid property once again?
Sir,
okay. So you take one practical example. Again, the standard example. You are withdrawing some amount from ATM. Okay, so it is called as a transaction. Okay, one simple example for a transaction is withdrawing some amount from ATM is an example for a transaction. So you are initiating a transaction. So how will you initiate a transaction? You will insert the card, you will provide the PIN number, and you will enter the amount. So the thing is what? So what is the lifetime of a transaction? Time duration between the initiation and the termination. So in the normal case, so the amount will be debited from your database and the amount will be dispensed to you. This is with the normal case. Now suppose you consider a different scenario. Okay. So you have given the amount and you have given your PIN number. So the amount is debited from your database, or that is amount is debited from your account. But before dispensing, there is a problem, or you are having some abnormal program termination, or some power failure, or there is a problem in your ATM machine. The amount is not dispensed. So in that case, this is not a valid transaction. No user will accept it. So suppose you are withdrawing 5,000 rupees. Okay, no problem. So let the bank enjoy the 5,000 rupees. You won't leave like that. Okay, so that is the idea behind atomicity. Atomicity means, so you are having a transaction, suppose you assume that you are having some 10 instructions. So first one is insert the card, second one is enter the language, third one is enter the PIN, enter the amount. Like that, you are having some set of instruction. You need to execute all those 10 instructions. You cannot abruptly terminate the transaction. Suppose if you are going to have any error in the middle, what you need to do is you need to perform what? You need to make the database in a consistency. That is, you need to move to the what? You need to move to the beginning of the transaction. You need to restore the old state of the database. So what is the state of the data? What is the content in the database before starting this transaction? You need to restore the database to that particular state. It is atomicity. Consistency means you are performing an operation. So see, suppose for consistency, suppose you assume that there are two accounts, or you assume that you are having 1,000 rupees in your account. Your friend is also having 1,000 rupees in his account. Now what you are doing is you are transferring 500 rupees to your friend's account. So now what is the sum of amount in these two accounts before transaction and after transaction? Before the transaction, if you perform the sum operation, 1,000 plus 1,000, 2,000. So after the transaction also should be what? 500 plus 1,500. So 500 rupees will be debited from your account and 500 will be credited to your friend's account. So 500 plus 1,500, it will be what? Again 2,000. This is in the normal case. So now suppose the 500 rupees is debited from your account, but it is not credited to your friend's account. So in that case, so what is the total amount before the transaction? Before the transaction, total amount is 2,000. After the transaction, what is the total amount? The total amount is 1,500. So this is not a consistent state. So you need to ensure that is your transaction needs to move the database from one consistent state to another consistent state. It should not lead to any inconsistency. So third one is isolation. So your transaction, as part of transaction, your transaction may generate some intermediate values. You should not allow the other transaction to do some computation based on the intermediate values. So you may ask a question, sir, what is the problem? See, there is no guarantee that your transaction will complete successfully. In some situation, there may be a need to abort the transaction. Suppose if you are going to abort the first transaction and the second transaction input is the output of the first transaction. So unnecessarily what you have to do? You have to abort the second transaction also. So that is the idea behind your isolation. Durability means once you see, initially the output generated by the transaction will be stored in the temporary buffer. So each and every value will not be updated in your database. If you are going to update each and everything in the database that is residing in your secondary storage base, time will be what? It will consume more time. So usually certain data will be there in the primary memory. So your manipulation will be based on the content, and we will refer it as a buffer. So after finishing the transaction, you need to update the database. So after updating the database, I cannot perform any undo operation. You need to execute a what? You need to execute a compensating transaction. Okay, so without executing the compensating transaction, you cannot modify the state of the database. So that is the idea behind your durability property. Whether it is clear or not?
Yes, sir, clear, sir. Thank you, sir.
So any other doubt? Can I continue with the next topic? So next idea is who are all the persons involved in your database environment. So first category is actors on the scene. So now again you can recall the examples what we have discussed in the last class. See, now the thing is, again the concept is very simple. If your database is going to be very small, or if it is you have created a database for your own personal use, in that case you are going to be the one and only user with respect to that particular database, or you are going to be the one and only person associated with the database. So if your database is going to be a small personal database similar to the address list, so everything, database creation, database value insertion, manipulation, updation, everything will be done only by a single person. Your database is not going to be shared with the other users. Whereas practically, if you take a database related to a company, database related to a bank, or database related to a university, in that case, you cannot say that only single person is involved in the database operation. So in that case, you will be having what? Many people are involved in the design of the database, use of the database, and the maintenance of the database. So suppose your database may be having water, so you may be having multiple users or more number of users interacting with the database. So if your database size is going to be large and if you are going to have more number of users, and in that case you need many persons or you need to employ multiple persons in different roles. So these are the persons involved in the actors on the scene. Okay, so you will be having for each and every database, you will be having a database administrator. Take any organization, if you want to allow more than one person to access the same resource, you need a what? You need an administrator to manage these resources. So now, if you take a database environment, your primary resource is the database, and what is the secondary resource? Secondary resource is your database management system, and the code or the programs or the software related to your database management system. Now, what is the role of this database administrator? So, your database administrator is responsible for, suppose, is responsible for providing access to the database, that is, authorizing the users to the database. Your DBA is responsible for authorizing access to the database. Your DBA is responsible for coordinating and monitoring its use. He is also responsible for acquiring the software and the hardware resources. So, if you are going to have a security breach, when will you have a security breach? If your authorization mechanism is very weak, then in that case you are going to have a security breach. Or if the response time is going to be poor, who is responsible for that? Your database administrator is responsible for that. So, role of database administrator is to authorize the what? Authorize the users, coordinating, monitoring the what? Monitoring the use of the resources. In order, suppose if there is a demand, if you are going to have, if the size, if the volume of data, what you are going to store in the database increases rapidly, then in that case he is responsible for adding the storage capability to the existing database. So these are the functionalities related to your database administrator. So second category of person is the database designer. So actually these are the real persons who interact with the end user. Suppose if I am going to be the end user, so I am giving you the requirements. So what is the need is you need to create a database according to my specification. So your database designer is responsible for interacting with the end users, identifying their requirements and designing or finalizing the structure of each and every table, identifying the constraint, identifying the data type. Everything is responsible. Who is responsible for all these things? It is the responsibility of your database designer. So what we can have is, so depending upon your budget or depending upon the application, there is no need to have a separate database designer and separate database administrator. So this is going to be the initial stage. So what you can have is the same person. Initially the same person may be the database designer. Later, after finalizing the design, the same person can act as the database administrator. So these two things are, you are not going to have what these two activities is not going to overlap. Okay. So third category is end user. Okay. So again, you can classify the end users into 4 types. Actually, these are the persons who really interact with your database using the various query languages. So first type of end user is called as the casual end user. So these people, okay, so casual end user means from the name itself what you can infer, they are not going to interact with the database regularly. So for example, if you take an organization, top level management, so top level management person comes under the category called as casual end user. They may be interacting with the database once in a month or once in 15 days. They want to identify the water. They want to identify the profit percentage. They need only some data. They are not interested in what? They are not interested in day-to-day activity. So these are the person who will interact with the database occasionally, but for each and every time they try to extract some new information, or they are not going to repeat the same query again and again. So they will interact for each and every interaction. They need some different information, or for different purpose they will interact with the database. So for interacting with the database, they will be using the sophisticated query language. So these persons are generally called as the middle, or usually middle or high level managers comes under this particular category. So that is the first user called as casual end user. Second one is the naive or the parametric end user. Okay. So these are the persons who are going to be regularly interacting with the database. So what is the work of these person, or what is the job of these person is, so these person will, okay, so the thing is constantly they will be querying the database and they will update the database. For interacting with the database, these users will make use of the canned transaction. Okay, so canned transaction means so they are going to use the what? They are going to repeat the same transaction again and again. So canned transaction is nothing but the code that is so existing code or carefully tested code. Okay, so that is the idea of your canned transaction. So example for this parametric end user is, suppose if you go to a bank, so you will be having a clerk. So what is the role of the clerk? So role of the clerk is to perform what? So withdraw or deposit operation, they will perform the same operation. So they will, whenever you submit the withdrawal slip to the clerk, they will enter your account number, they will check for the balance. So if you have sufficient balance, your withdrawal slip will be passed. Otherwise, it will be denied. So they are going to repeat the same operation again. Or in other words, another familiar example is what? Railway reservation clerk. So what is the operation performed by the railway reservation clerk? Only two operations. One is either it may be booking or it may be a cancellation. So apart from that, they are not going to perform some other operation. So these type of users are called as naive or parametric end users. So third one is the sophisticated end users. Okay. So actually these are the persons. So what is the difference is, if you take the previous two cases, these persons is not going to have any knowledge about the database or database management system. So the third category people, that is sophisticated end users, include your engineers, scientists and business analysts. Okay. So these persons will have some basic idea about the database and they are familiar with the functionality of the database management system. What are the various modules available in the database management system? So what is the uniqueness is, based on that they can customize the database management system according to their own requirement. So those type of users are called as sophisticated users. And finally, last category is called as what? In the end user, fourth category is called as the standalone end user. So these person, okay, so standalone end users, they will be using some predefined packages or predefined programs or readily available programs. So usually the interface is going to be what? So these type of users will be provided with a menu-based interface or a graphical user interface. So one example is, you can have a financial software. Okay. So what are, suppose for example your Microsoft Excel. So what they will do is, they will use the readily available software or readily available program, ready-made program that is available. And again, they are not going to have any additional information about the database account. So you can classify the end users into 4 categories. One is called as casual end user, second one is the naive or parametric end user, third one is the sophisticated end user, and finally fourth one is the standalone end user. So the last person in actor on the scene is system analyst or application programmers. So your system analyst is responsible for determining the requirement of the end users. So your system analyst provides, or your system analyst develop the specification for the requirements, and it is the responsibility of the application programmer to develop the code according to the specification given by your system analyst. So your application programmer will develop the program or will develop the application. Then after completing the development process, the code need to be tested. If you are going to have any error, you need to debug the code, and finally you need to have a proper documentation for that code. And what you need is, after deployment, you need to maintain that code. So if you are going to have some predefined code, or these application programmers are responsible for what? These application programmers will be used by your naive or the parametric end users. So with this, I will stop. Okay. So already time is 4 o'clock. Okay. From the next Thursday class, I will start with the workers behind the scene. Okay. So if you have any doubt up to this, or what are the topics I have covered so far, you can ask. Thank you.